approaches 3, x squared plus 5x plus 6 over x minus 1. I don't know why everyone on the test, this problem seems to be everyone gets the hard ones. This one, students miss, I get a kick out of it. I always get a kick. They think they gotta go and do all this algebraic manipulation and factor and all this stuff. They start factoring right away and stuff. There's no need for that, is there? We just talked about this. What can we do? Just what? Yeah, check to see. I mean, we only have to manipulate if we get that 0 over 0. Then we sit there and go, okay, but if you get a number, that's your limit. So put it in there. I mean, you're not going to get 0, 0, are you? What's the denominator?
2.
2, and this is just some weird number. What is it? 9?
30.
Is it 30?
Yeah.
30. Can we reduce that?
Yeah.
There it is. Done. I'm laughing. I'm serious. I'm like, when I always go, I get to I'm like, oh my gosh. They got all the hard ones. And at the end, you start factoring this. They start seeing if they can cancel things, right? All this algebraic steps.
Now what about as x approaches 1?
Aha. That's a good one. Let's do that. I like when students create the problem. That was good. All right. Same expression, everyone. On the limit. X approaches 1. Okay. 1 plus 5 plus times 1 plus 6 is. So we just substitute. We're using limit laws, by the way. If you went through all those limit laws, 12. Thanks, Joe. What's the bottom now?
Yeah.
I bet you know the answer then. That was a good question. You came up with the problem. What do you think the answer is to that answer? I bet you know. What's the right answer? There you go. You got it. We said that's not 0 over 0. See, if we got 0 over 0,
Yeah.
then we're playing.
Let's do one of those.
I like it. All right. So when he was, let's do one of those. Okay. X approaches. How about -2? But this time, I changed the denominator. All right, what do we do? Before you start manipulating, remember I always want you to do this, try to what? Yeah, plug it in. See what you get, because if you get 7 over 0, put 0. You get 12 over 0, I mean, it does not, you get a number, pick a number. But let's just see, I plug in -2, I get what? Ooh, you get 0 on the top. What do you get on the bottom?
0.
There it is. They call that indeterminate form. So the answer is not 0, is it? You go, what do you do? It's playtime. You go, don't stop. You go, all right, I got the indeterminate form. I'm going to go back to this expression, and I'm going to use every tool in my algebraic experience to manipulate this thing. Any suggestions? Factor. There you go. So there's the first word when he comes up. It's like things to try. He goes factor. Good on. Good thing to try. You look at some of you go, well, maybe I can factor. And can you factor the top?
Yeah.
X plus 2 and x plus what? These cancel?
Yeah.
Now, take that number, substitute it. What's the answer? -2 plus 3 is a 1. That's your limit. Isn't that cool? Isn't that cool? Now, I was going to pull out the graphing calculator, but I don't need to. If you wanted to check this problem, you're on a test, you're like, I want to make sure I did this right. That right there, since it's simplified, you get this. Isn't that just a straight line? That's a straight line. So I just want to let you know in algebra, this expression, f of x equal to x squared plus 5x plus 6 all over x plus 2 really is a straight line. It really is. Because you all just saw it. What cancels? The x plus 2's cancel out, right? But this straight line has a hole somewhere. It has one little tiny hole. It's infinitely small. Where's the hole? -2. Because this is the original expression. So if I graph this line, everyone, and you all know how to graph the line y equals x plus 3. The y-intercept's what, 3?
You rise one, run one, rise one, run. This line is just going like this, right? It just keeps going up like this. But at x equal to -2, when you put that -2 in there, it's like right over here. Right there, there's a tiny hole. Because it didn't exist there. But it's right at that +1. So what's it approaching from the left side?
-2.
You know? It's approaching that +1 value, right? What's it approaching as you go towards -1, -2 from the right side? Approaching that. Does that make sense? So I'll label this. So when this was -1, that right there was -2. That's it's always we put the, so as you approach x equal to -2 from the left, you're approaching a 1 with a hole in it. As you approach -2 from the right, you're approaching that hole right there, but you're approaching the same number, aren't you? If you graph it on your calculator, will you see the hole? No, because it's infinitely what? Small. You won't spot it. But if you look in table, it'll give you a little message like D and E. It'll say, hey, there's nothing existing there. Isn't that cool? So you can always check it on your calculator. You go, oh yeah, it's just approaching a 1. You can look at these things graphically. All right, great job. All right, try this. See how good you are. Hey, the bottom 0, right? Maybe it's indeterminate form. Always make sure though. What's the top? 9 plus 15, 24 plus 6 is 30? What do y'all think? D and E. That's not indeterminate form. Does not exist. Does not exist. So you go, oh, is that a straight line? No, that's not a straight line. Look at your calculator. You're getting one of these funny rational expressions, rational functions. It's a rational function. It's crazy. It's got a slant asymptote too. But it does not exist as a pretty tree. Alright. Try this one. How about x squared minus x minus 12 over x minus 3. And after you do that one, try this. Minus 3. X squared plus x minus 12. It does look like the same problem, doesn't it? I'm trying to emphasize, always check first before you start manipulating to see if you get 0 over 0. Don't manipulate unless you get 0 over 0, right? Always check. You get a number, that's it. You get something over 0, 5 over 0, D and E. Is this 0 over 0?
Sig negative 6 minus 0.
Ah! We already know the answer then. D and E. So that's my point. Like, I'm not doing any factor until I make sure I've got 0 over 0, right? That's when I have to play. And probably get an answer. So hey, it's done. It's not 0 over 0. Negative 6 over 0 is undefined. Hey, also Matt, I did a bunch of over zeros. What if you got 0 over 7 again?
0.
That's 0. That number, everyone, does exist. That's 0. So if you ever get 0 over 6 or 0 over 7 or 0 over 10, that's 0.
I have a question.
Awesome.
What is the difference between like a number over 0 and 0 over 0?
I love it. So 0 is, that's what it's like defined mathematically as the indeterminate form expression, right? Like a number over 0 we know is undefined with these algebraic expressions. 0 over a actual finite number is 0. But when we're dealing with these limit laws and we have these algebraic expressions, okay? If you get the 0 over 0 scenario as you're trying to find a limit, that usually indicates that somehow, some way, that algebraic expression there can be manipulated and rewritten in another way to allow you to evaluate it. The only thing is, and I think you understand this original expression right here the actual function, this is a function, it does not exist at the x value of what? 3, right? It definitely doesn't exist there. But it's just the scenario that we determine, we call the indeterminate form. But it's really with these limit laws. That's the only time we're dealing with it, the 0 over 0 scenario. The indeterminate, only with limits. Hey, what do you get on top?
0.
Oh boy, here we go. Doesn't that mean play?
Yeah.
Alright, we get to play. Any suggestions?
Factor.
Factor, alright. So what's the top factor?
X plus 4, X minus 3.
Ba-boom. Knock him out.
Take out X minus 3.
7.
7.
7. 7. Even a final exam, you get ones like this, you know?
And then there's
It's
no-
like mid-July, you're like, all of a sudden, you're like, oh, let me see if I get 0 over 0. If not, just put down DNE, right? Yeah, what's the problem? I always get a kick out of this. Gets everyone on a final.
Do you always just factor, I guess, if it's like that?
No,
Or is
good
there
question.
other-
There's other ways, and they're coming up. It's gonna be a few more things here, but when we're done here, Joe, it's probably gonna be about 4 things. Factoring, common denominators, conjugates, and then we'll come up with a 4th one and say, what else is there? And I think the 4th one, we'll just look at something. If none of those work, we'll just end up expanding it. Do you know what I mean by expansion? You just start distributing everything. You just distribute everything that they have. They might have it all factored already, and you just distribute and see if you can get the thing to be manipulated. Cool? So that list will grow. I just wanted to show you something. Ready? Yeah, look, you're on the final. Now here we go, it's a natural log, right? But heck, you got a calculator with you. You don't know what the element of 1 is. You can check it on a calculator. I bet you know what the element of 1 is, though. Natural log of 1 is what? 0. Yeah, a few things it's good to know in math. Without the calculator, you know the calculator would do it. It's good to know e to the 0. And it's good to know ln of 1. What's e to the 0 power? 1. Comes up a lot. Comes up a lot. What's ln of 1? 0. But you can still hit ln 1 on that. So anyways, what are we getting?
DNA.
DNA? And a lot of students, you know, probably make the graph, you try to look at the graph, probably looks kind of funny, and they choose another, you know, putting other answers down. There you go, that's it. But I'm with Joe Erwin, great job with that, was everyone okay with that? But like, come on, give us some of these other scenarios. So if you have your textbook, great, if you don't, it's all right, I'm gonna write these problems on the board. I want us to focus on problems number 11 up to about number 27 or so. All right? They're really good. I put them in your practice problems, so you'll practice all these. I'll try to stay even now because you all practice the odds. Well, we already did one like number 11. We already did one like number 13. Yeah, we did one like 15. How about one like, I'm going to go down this list. I'm looking for it. I see it. And when I want to give you one like number 23. Okay? All right, here we go. This problem, if you want to write down, it was like number 23 from the textbook. X approaches a negative 3. 1 over 3 plus 1 over x all over 3 plus x. And it's an algebraic expression, it's a two-sided limit. What's the first thing you'll do? According to limit laws, we're going to try to substitute this thing. But if we get 0 to 0, indeterminate form.
Put the negative sign on the other side.
Oh, yeah. And but if we plug that in there, what do you get for the top numerator?
0.
We get 0. The bottom?
0.
There it is, Owen. So right now, we're saying, okay, the limit may exist. Right? Is it indeterminate? There's a way we can manipulate the expression. We can manipulate it. That word I use, manipulate. Factoring's not going to work, though. So what do y'all recommend? You got it. Common denominators. Whatever way you like, that's called a complex fraction. So whatever way you like dealing with complex fractions, do it the way you like. Alright, here's the way I'll instruct it. Alright, I just want to get out a different colored chalk. 3 and an x, the common denominator is 3x, right? So I have to multiply an x here and an x here. Over here I have to multiply a 3 and a
3. Okay, let me just draw an arrow. It looks like I have an x plus 3 all over 3x. What's down here? What's this 3 plus x over there? Oh, alright. So let me make sure, am I okay with that? This is the idea of common denominators. I had to somehow, I wanted to manipulate this, so I'm going to add these two things together. Well, to get a common denominator, I had to multiply an x over an x, and I had to multiply a 3 over 3. And then when I add them, the common denominator is 3x, and I get x plus 3. Is everyone okay with that? Yeah? So the bottom, it just had 3 plus x, right? But I'm like, but what is it over? It's invisible. What is this just sitting over? They're both over 1, so the whole thing's over a what? A 1. Now I bet you know how to deal with that. The flip, she was, that's what you gotta do. So take the bottom here and, multiply the reciprocal of the denominator. Alright, so we get, you get x plus 3 over 3x. Put a dot, and like she said, flip that. Multiply the reciprocal of the denominator. We're hoping something cancels. Anything cancel?
3 plus x.
Knock them out. You can put parentheses around these, they're gone. So this whole algebraic expression is equivalent to this expression, except for the fact that, we know this thing was undefined at -3. But, according to limit laws, this is still going to produce our result. Stick it in there, what do you get? What's the limit?
1 over -9.
That's it. Hey, backup book probably won't write it this way. Even though I changed it when I did a problem like the one in the book. How do they write fractions that are negative? They put the negative where?
At the front.
They put it right in the middle. You can put one, you can put it on the top, you can put it on the bottom, or you can put it in the middle, it's up to you. Just don't do top bottom, you just made it positive, right? Cool. So, our list is